Hello students, this is Rutuja Kadam from Symbiosis Institute of Technology. Let us start with an important topic in computer organization. Today we'll learn about the von Neumann architecture in computer organization. So, what is the objective of the session? The objective of the session is to learn the basics of the von Neumann architecture. Learning outcomes, that means at the end of this session what you will be able to grasp. The first thing is you will understand the importance of von Neumann architecture. You will have a brief idea about the features of von Neumann architecture. So in earlier days, there was a computer called as Colossus, which was the first programmable electronic digital computer. It was built in 1943 in World War II. In the right hand corner of the screen, if you are able to see, this is the picture of Colossus, wherein the size of this computer was very huge. There are two ladies who are working on the cables and switches of the computer. You can see multiple electronic devices in the picture. That is nothing but again these are the various parts of the Colossus computer. Now, if you see the basic history of the computer, you will always find that American NIS is generally said as the first computer. But prior to that, Colossus was invented, but it was kept as a national secret. Why it was kept as a national secret? Because it was used in World War II. There were certain demerits of Colossus. Now, what was that? The data and programs were stored in two separate memories. Now, what is the difference between data and what is the difference between data and program? Program is, let's say if you consider a C program, in the C program you will write printf statements, scanf statements, some computation statements, such as, let's say if you want to write a program for addition, then you will write a statement such as C is equal to A plus B. These are called as computation statements. But what is A and B? These are the variables on which the computer program will work. Now that is nothing but the data, because your program will work on that data. So in Colossus we had data located or stored separately and programs stored separately. Now with this, what was the limitation? Again, if these two were located at two different places, then if you want to execute a new program or if you want to re-execute the same program, at that time there were many rebuilding of switches and cables that used to take place in this particular diagram. If you see, there are n number of cables and switches that are there. So to re-execute one program, the programmers had to switch the wires and the cables and the switches many times. So this was chaotic and this was a very difficult task. Obviously, it was a time-consuming process. Now, the size of the computer was as huge as one room. Obviously, then maintenance would be huge. Why maintenance would be huge? Because in a computer whose size is of one room, no dust particles, external particles should enter the component. Why? Because if, let's say, if a dust particle gets accumulated on certain electronic part, then it would dissipate heat and it would lead to a damage to a particular component, and obviously it would it will give incorrect results. And so these were the demerits of Colossus. So von Neumann architecture was developed. Who developed it? John von Neumann, who was a scientist, who was a great mathematician, who contributed to set theory, which you will be learning in DMPT subject, then game theory that you play on your mobiles and your computers. Then he also contributed to Manhattan Project. This Manhattan Project was the first atomic bomb project. Then you might wonder, what was his contribution to computer science field? Or else we can say, what are the key features of von Neumann architecture that he developed for the computers? So basically in Colossus, if you remember, I had said that the Colossus used to store data and programs in two separate memories. So John von Neumann proposed such an architecture in which data and the program Both are stored in the same memory unit. So John von Neumann proposed such an architecture which was able to store both programs and data into same memory. Now what happened with this innovation? So if both the data and programs are stored in a same memory, obviously if we want to re-execute a program or rebuild a new program, it becomes more easier for a programmer. Obviously, the execution of instructions was taken place in a sequential fashion. What do you mean by sequential fashion? Sequential fashion means one after the other. Unless and until the first execution is completed, the second instruction will not start its execution. So this was again one of the key features of von Neumann architecture. So this fundamental design, the fundamental of design of storing the program and data into the same memory is followed by all the modern computer systems even today. Now let us see the von Neumann architecture. This is a block diagram of the von Neumann architecture. So here if you can see, this is the input device, this is the central processing unit, this is the memory unit, and the fourth one is output device. So basically 4 parts we have. In central processing unit, again we have central processing further divided into 3 parts, that is control unit, then there is arithmetic logic unit, then we have registers. Registers, again there are PC, CIR, AC, MAR, MDR. PC stands for program counter, CIR stands for current instruction register, AC stands for accumulator, MAR stands for memory address register, and MDR stands for memory data register. Now I will be explaining these registers in detail in near future. Right now you just keep in mind that there are basically four blocks in the von Neumann architecture diagram. So let us see what do you mean by input part. So this is the process of entering data and program into the computer system. Examples of input devices are mouse, keyboard, joysticks, etc. Control unit, so responsible for decoding the instruction. Here the word decoding is a new word for you people. So what do you mean by decoding? Now I want you people to understand this particular concept very clearly, because this is again the basis for many other concepts in computer organization. So what is decoding? So when you write a C program, you write in a human readable language, or else we can say that you write in a high level language which is understandable by human. Printf, scanf, this language is not understandable by computer. What type of a computer understand the language? It understands the language which is in the form of zeros and ones. So whenever we want a program to execute which is written in a high level language, that needs to be converted into lower level language, that is in the forms of zeros and ones. So this process of converting high level language to the lower level language is nothing but decoding process. Okay, so that is the major function that has been done by control unit. Now it controls all the operations such as input, output, processing, storing data. So basically control unit acts as a manager, or he can act, he is a controller who will control all the activities in the computer that is taking place. Okay. Now let us move to the next part, that is arithmetic logic unit. Arithmetic logic unit, as the name itself suggests, performs all the arithmetic and logical operations. Also it performs comparison operations. Arithmetic operations means addition, subtraction, multiplication, division, and logical operations are and or not. And comparison operations are greater than, lesser than, equal to. All such operations are performed by arithmetic logical operations. Then the next part is memory unit. As everybody knows that a program will have data into it. Now where do we store this data and program? So this information must be stored in the form of bits. What is bits? Bits is nothing but binary digits. When we say binary means 2. 2 means 0 and 1. So any information in a computer is stored in the form of 0 and 1. So information is stored in the memory unit. then each memory location has a unique address. It is the same concept which you can map to the real-time concept, such as your each individual student will have a unique PRN number. Likewise, each memory location in the memory will have a unique address, so that if any program want to address, it can be able to address it individually. Then comes bus. What is this bus? So in this particular diagram, if you see these arrows, if you can see, these wires are nothing but buses. These buses are nothing but wires which are able to transfer the data between the different components of the computer. Also, there are three different types of buses, that is address bus, data bus, and control bus, that we will be seeing later on in the later lectures. Also, I want to tell you that data transfer rate, or the data transfer between various parts of the computer, depends on the size of the bus. Now, size of the bus that is connecting these two components. You might say that yes, sometimes you might wonder why my PC is running so slow. Then the reason behind is that the capacity of the bus, or the data transfer rate of the bus, is very low. If you increase the if you increase the size of the bus, the data transfer rate also increases. So likewise. Then comes the register part. Now this register, first of all, I would like to tell you, this register is a small, or let's say these are the specific memory locations which have specific purposes for it. Now these are the small data stores of data with CPU, within CPU, that is they are mounted on the CPU chip itself. These are the memory locations itself, but they are mounted on the CPU. When they are close to CPU, obviously its performance, or let's say it is the fastest memory of all. Now before going to anything else, I would like to clear certain basic concepts which will be needed for you in operating systems, as well as you will be requiring for the entire computer organization subject that you will be studying. So when you store a program, or let's say you are writing a program, C program, and you want to save it, where do you store it? In a hard disk, or let's say in a secondary storage device. Let's say you store a program with as C drive abc.c, where C.c is the extension of C program. Now when you want to execute this program will never ever execute itself from the hard disk. It is just stored in the hard disk, but when you want to execute this, the program needs to be first loaded into the main memory, and then it will be executed by the CPU. So you have to keep in mind that the program will never ever execute itself from hard disk or from secondary storage. It has to be first loaded into the main memory, and then only it will execute itself. Okay. Then each instruction and its related data can be fetched serially one by one. Now here again, what do you mean by fetch? So fetch is again a new word. Fetch is the process of bringing the program for execution from secondary storage device to the main memory is called as fetching the instructions, or fetching the program. Now this fetching is done one by one. Now what is one by one? That is in sequential fashion, that I've already explained you. And where do we bring this fetched instructions? We bring into the registers. Where are these registers stored? These registers are stored on the CPU, and ultimately they are executed by the CPU itself. So this is the basic. You have to keep this in mind, that whenever you want to execute a program, it has to be first brought into the main memory, and then only it will be executed by the processor, right?